So I'd like to go through a couple of torque questions which have all been extracted from previous past papers, trial exams and whatnot. This question here is not an application of tau is equal to NBI equals theta, it's actually an application of tau is equal to force times distance. Remembering where that's our generic torque equation, where the force could be, in this case it's force due to weight, but it could be any force which causes a rotation about an axis. Okay, so what we have here is we've got a 2 kilo object on the left hand side, a 14 kilo object on the right hand side. What some students do right there is they see that we've got 2 on the left, you've got 14 on the right. They're kind of like the net mass is 12 on the right. Okay, although that is true, the rotational effects are actually going to be different because they're different distances away from the point in which they're turning around. Okay, now if they were both 0.3 meters away from the point that they're turning around, that method is fine. Whereas here we actually have to evaluate the torque due to each one. So let's go about solving the problem. So we've got our 2 kilogram mass over there on the left hand side. Let's figure out the torque due to the 2 kilo. So torque due to the 2 kilo is just force times distance, where force in this case is our weight force, so it's just mg times d. Now the mass is 2 kilos, g is 9.8, and the distance is 0.2 meters. Okay, so that'll give us a torque of 3.92 newton meters. Now direction, the force on this side is going to be down, which is going to cause this entire thing to rotate anti-clockwise. Okay, so that's anti-clockwise. Now the torque due to the 14 kilo mass, so torque due to 14, is again force times distance. Force is mg, so here we've got 14 times 9.8, times our distance in this case is 0.3 meters. Okay, so if you work that out, that'll be about 41.16 newton meters. Okay, that's clockwise. Okay, why is it clockwise? Because if I apply a downwards force on this side, it's going to make this entire seesaw move in a clockwise direction. So you can see that those two torques are in opposite directions, so what do? We subtract the small one away from the big one. So our net torque is 41.16 minus 3.92. And the answer which is closest to that is going to be our answer of D, 37.24 newton meters. So our answer is D.